Hello and welcome to Chem 1. This is lecture 2A and we'll be discussing chemical foundations within this lecture. To start off with, I want to talk about the structure of the atom. So within the atom we have the nucleus, which is a small dense center of positive charge in an atom. And within the nucleus we've got protons and neutrons. Protons are the positively charged particles. Neutrons are a particle that has approximately the same mass as a proton but does not have a charge. And then we've got electrons, which are a negatively charged particle that occupies the space around the nucleus of the atom. To get a visual of what we're talking about here, we've got my protons and neutrons that are located in the nucleus space of the atom, and then I've got electrons that are located outside the nucleus, typically in electron shell, or we can call this electron cloud. So on this slide, I'm just kind of going over the same information again. Electrons, we often abbreviate lowercase e with a minus sign. It's outside the nucleus. It has a -1 electrical charge, and its relative mass to protons and neutrons is a fraction of protons and neutrons. So it's 1 over 1840. Protons, we often use the symbol little p with a plus sign. It's located in the nucleus. It has a +1 electrical charge, and its relative mass is 1. Then we have neutrons, which we use the symbol lowercase n with a 0. It's in the nucleus. It does not have an electrical charge, but does have the same relative mass as protons. So we've got some information about elements. The name of the element and its chemical symbol are given in each box on the periodic table. The symbol for an element, only the first letter is capitalized, and then any other letters would be lowercase. The integer in the box represents the element's atomic number. So for our example that we've got on this slide, our 6 would be the atomic number, which is also the same as the number of protons in the nucleus of the atom for that element. So looking at the periodic table of elements, I can see lots of examples. On this particular table, I've got atomic number, I've got the element symbol or chemical symbol, I've got the name, and I've got the atomic mass. Alright, a little more information about elements. The elements are arranged in order of increasing atomic number, and the sequence of atomic numbers has no missing values. This continuous series is an indication of the fact that atomic number determines the identity of the element. So looking back at my periodic table, I can see that my numbers go from 1 to 2, 3, 4, and so on. In a later lecture, we'll talk about why this large gap exists in the top of the periodic table, and then why we pull these two rows out from the middle of the periodic table. So more information. Atoms have no net electrical charge because they contain equal numbers of protons and electrons. In other words, positively charged protons and negatively charged electrons balance each other out. So electrons, protons, and atomic number are related as follows. The atomic number equals the number of protons, which equals the number of electrons. And I want to emphasize that this is the case for neutral atoms. We'll discuss later where this is not the case. Well, atomic number of protons are always the case. It's with the electrons that'll change. So let's do a little bit of practice. So how many electrons and protons are contained in an atom of each of the following elements? So letter A, arsenic. If I look at the periodic table, its element symbol is As. Its atomic number is 33. So if its atomic number is 33, then my electrons and protons are also 33. Letter B, gold, is element symbol Au, and atomic number 79. So electrons and protons are 79. Letter C, fluorine, is abbreviated as F, and its atomic number is 9. So electrons and protons are 9. Alright, letter D, molybdenum Its element symbol is MO. Its atomic number is 42. So protons and electrons are 42. Letter E, polonium, element symbol is PO. Atomic number is 84. So protons, electrons are 84. Letter F, barium, its element symbol is Ba. Atomic number 56. So protons and neutrons, protons and electrons are 56. So let's look at that a little differently. If I'm given the number of protons, or which is the same as the atomic number, what element am I dealing with? So letter A, I have 34 protons, which is element number 34, which is selenium, or element symbol Se. Letter B, 5 is boron. All right. Letter C, gallium. Letter D, 61 is promethium. And then 94 is plutonium, or Pu. Alright, next slide we're going to talk about isotopes and mass number. Although all atoms of an element have the same number of protons, most elements have atoms with different number of neutrons. So atoms with the same number of protons but different number of neutrons we define as isotopes. An isotope of an element is identified by its mass number, which is the sum of the number of protons and neutrons. And the relationship, we have mass number equals number of protons plus the number of neutrons. And I want to emphasize here that the mass number is just the rounded form of the atomic mass that's shown on the periodic table. You can see that the atomic mass that's shown on the periodic table has several numbers written after a decimal. What we do is we round it to the nearest whole number for ease of use, so we get a whole number of neutrons. Alright, so on this slide we're going to be looking at how do we write isotopes. So on my first example, I write either the element name and then I put hyphen with a mass number afterwards. And these are just two different examples, so I can put hydrogen 1, hydrogen 2. I can also write it as the element symbol, so H1, H2, or hydrogen 1, hydrogen 2. You can read this the same way as you read this one, just a lot less to write here. Or we can write it with the atomic number also. And the top number is the mass number, the bottom number is the atomic number, and then obviously the X or H in this example is the element symbol. The A over Z, the big X, is a general form that we can use, but then we've got actual examples here. So hydrogen 1, hydrogen 2. So recall that the number of protons in the atom's nucleus is the atomic number. So if we substitute the atomic number for the number of protons, we get the following relationship. The number of neutrons is going to equal the mass number minus the atomic number. So the last thing we're going to do is practice figuring that out. So we've got some isotopes here. Letter A, I've got carbon 12. 12 is the mass number. So I'm going to take 12 minus the atomic number, which is 6, to give me 6 neutrons. Carbon 14. I have a mass number 14. My atomic number is still 6. So 14 minus 6 gives me 8. Aluminum 27. Take the mass number 27 minus the atomic number, which is 13. And I get 14 neutrons. Alright, then iron 56. minus the atomic number of 26, I get 30 neutrons. Alright, so this ends our lecture on chemical foundations.